Okay, let's take a look at example 9. A radioactive source contains 1 exponent negative 6 gram of plutonium-239. So plutonium is a particle that is usually used in nuclear weapon. Okay, if the source emits 2300 alpha particles per second, calculate the decay constant and the half-life. So we have plutonium-239. The mass is 1 exponent negative 6 gram, and then it emits 2300 alpha particles per second. So kalau dia cakap dekat sini alpha particles per second, meaning that it is the activity. So it is the activity, and then given the mass is 1 exponent negative 6. So what we want is the decay constant and the half-life. Okay, so if we refer to the list of formula, okay, for chapter 11, so we have especially for this subtopic, so for this subtopic we are going to use this formula here, di mana kita akan ada the decay rate dekat sini ataupun activity, and then decay equation in terms of the number of nuclei, and then activity equation in terms of the activity and the half-life equation. So just now we want to find is the decay constant, which is this one, lambda dekat sini. So dekat sini all of these have the lambda, so we need to decide which equation do we need to use. Okay, so based on the information, okay, information yang kita ada is the activity, which is 2300 alpha particles per second, and then we have the mass. So we have activity and the mass. So in order to find where is it? Okay, in order to find the decay constant, so kita boleh guna this one because we have activity, but this one we don't have initial and the value for t dekat sini. So what we can do is we can use this formula, di mana dn over dt ni adalah sama juga dengan A. It is actually the same thing. So we can use this formula in order to find the lambda, because we can't use this formula sebab formula ni memerlukan kita ada information untuk half-life, which we don't have. So we are going to use that formula, in which activity is equal to negative lambda times with the n. Okay, so here we don't have the value for n, the number of the nuclei, so we need to find this one first. Since we have the mass, so the formula is mass divided by molar mass is equal to the number of nuclei divided by the Avogadro constant. So mass dekat sini adalah 1 exponent negative 6 gram, and then since molar mass adalah the unit is gram per mole, so we can use gram here. So molar mass we can find it from here, which is 239 equal to n is what we want, divided by the Avogadro constant. So the nuclei number is 2.519 exponent 5 nuclei. So just masukkan dekat dalam formula ni, di mana activity is 2300 sama dengan negative decay constant is what we want, 2.519 exponent 5. Okay, so in the final answer we just ignore this sign, sebab sign ni hanya menunjukkan that the particle decay, so maksudnya dia berkurang daripada initial, so we just ignore the negative sign. So the decay constant is equal to this one is 15. This one is 15 as well. So decay constant is equal to 9.13 exponent negative 13. And the unit is per second. Okay, so the next one is you want to find the half-life. So now that we have the decay constant, kita boleh cari half-life menggunakan formula half-life is equal to ln 2 divided by the decay constant. So you get the half-life is equal to 7.59 exponent 11 second. The next one, example 10, uranium-238 isotope which has a half-life of 4.47 exponent 9 years decays by emitting alpha particles into thorium-234 nucleus. So we have uranium and the half-life is this value, and then we need to calculate. The first one is decay constant. So we need to calculate the decay constant, and then the mass, okay, the mass of the uranium, and then the number of particles per second. So remember, kalau per second, dia bukan n, dia adalah activity. Okay, kalau number of particles saja adalah n, but now we have number of particles per second, so it will be the activity. Okay, so now we have the half-life, which is 4.47 exponent 9 years. And now we want to find the decay constant. So we know that decay constant is equal to ln 2 divided by the half-life. Okay, so given the half-life here is in years, so we need to convert to second. Okay, kena convert to second. So ln 2 divided by 4.47 exponent 9. Okay, to convert to second we need to times with. So 1 year we have 365 days, and then 1 day we have 24 hours. And then in 24 hours we have, in 1 hour we have we have 60 minutes, and in 1 minute 60 seconds. So decay constant is equal to 4.92 exponent negative 18 per second. Okay, if you don't want to convert, okay, boleh juga. If you don't want to convert, you just leave the decay constant in terms of years. And then next one we want to find is the mass when the decay activity is this one. So we want to find mass, and given the activity is equal to 2.22 exponent 5 BQ. So this one is the SI unit for activity, which is actually it is decay per second. So we don't need to convert that one. Okay, so in order to find mass, we need to find, because we are going to use this formula, mass divided by molar mass is equal to N divided by Avogadro constant. So in order to find mass, we need to find the number of nuclei. So since kita ada activity kan, we can find using this formula. Okay, the activity formula, di mana activity 2.25 exponent 5 equal to negative decay constant is this one. So the value for n is equal to 4.512 exponent 22 nuclei. Okay, so again this negative you just ignore. So now that we have the n, so we can use this formula to find the mass. So mass is equal to 4.512 exponent 22 divided by the Avogadro constant times with the molar mass. So molar mass dekat sini adalah, because dia mahu adalah this one, right? Uranium 238. So this is the molar mass. So mass will be equal to 17.87 gram. Okay, so last one, we want to find the activity, which is number of alpha particles per second, when the mass of the decay is 30 gram. So now we are given a new mass, which is 30 gram, and we want to find the activity. So benda yang sama macam dekat atas, is just that dia punya flow akan terbalik lah. So in order to find activity, we need to find the number of particles first, number of nuclei first. So mass over molar mass is equal to N over Na. So the molar mass is still the same one, which is uranium 238 equal to N divided by 6.02 exponent 23. So number of nuclei is 7.59 exponent 22 nuclei. So now we can find the activity, which is decay constant is still the same. It's not gonna change. -18, and then times with this one, 7.59 exponent 22. So activity is equal to 3.73 exponent 5. Okay, since dia minta adalah number of alpha particles per second, so meaning that this will be the unit. Okay, we cannot use the unit for this one, because soalan memang minta number of alpha particles per second. So kena tulislah alpha particles per second. So this will be the unit. Okay, the next example, example 11. Initially, a radioactive sample contains 1 exponent 6 nuclei. The half-life of the sample is T-half. Calculate the number of nuclei present after 0.5 T-half. Okay, so we are not given the exact value of the half-life. So dia just bagi half-life is just this one. And then this is the value for N, which is 1 exponent 6 nuclei. So dia cakap this one adalah initially. So meaning that it is N naught. And we want to find the final number of nuclei after T is equal to 0.5 T-half. Okay, so this one, since we are given the value for N initially, so meaning that we need to find the final value, which means the formula that we are going to use is this one, the decay equation. Okay, because we are given the initial value, so we want to find the final value. So N is equal to N naught E negative lambda T. So just masukkan N adalah sama, N is what we want, and then N naught is 1 exponent 6, and then E negative lambda. Okay, lambda we don't have, but we know that lambda is equal to ln 2 over T-half. Okay, because we are not given this exact value, so we just substitute that one, ln 2 divided by T-half, and then we know that T is this one, 0.5 T-half. So we can cancel out this one, and this one, and then you will get the final value is 7.07 exponent 5 nuclei.